So today we're going to learn to differentiate. There are different ways of this word being used in questions. There is a derivative, differentiation, differentiate. Those are all the same things. We differentiate to get a derivative. All right? So what we're actually doing here is just a process. We're just going to learn the skill today. We're going to learn how, why, and all the other things in future lessons, but today we're just going to learn the skill. On your formula sheet, you will be given this. What that says is you've got a function that is part of a polynomial. It has a power and it may or may not have a number in front of x. It may or may not have a power too. But all numbers in a polynomial can be written like this. When we differentiate, we write it as a dash. That tells the person marking it you've done something to this. It's no longer f of x, it's the derivative of f of x. We have differentiated to get it. And what we do is we take that little n and we multiply by it. And then we subtract 1. So the sentence you want to learn this year is, take the power, multiply by it, and decrease the power by 1. That sentence needs to stay in your mind forever doing calculus. All right? Take the power, multiply by it, decrease the power by 1. You do those 3 steps, you can't get it wrong. If you don't learn to say it, you will forget to do part of it. The most common thing to do is to forget to take 1 off the power and leave a power in your question. People take the power and multiply it, they remember that part, but they forget what they're doing with the power in the meantime. So what does this mean? Let's have a look at a really easy one. If I say that y equals 6x squared, all right? Another notation or another way of writing our derivative is to say dy by dx. That says we're differentiating whatever y is, which is 6x squared in this case, by all the x's in it. So there's 2 different notations. There's this one and there's this one. They have fancy names. This one's called the Leibniz notation and the other one was invented by Newton. So Newton and Leibniz were 2 very ancient old mathematicians, physicists, and they discovered this on opposite sides of the world at approximately the same time, but we didn't have telephones or the internet, so they couldn't go, I found it. So when it was discovered, they don't actually know who found it first because they didn't write down dates in their notebooks or things like that. Well, they probably did, but they're both given credit on opposite sides of the world for finding the same thing. So that's Isaac Newton, and I don't know what Leibniz's name is. But anyway, so what we can write it like is this, or we can write it like this. So this one here, we take the power, which is 2, we multiply the whole thing by it, and we take 1 off the power, so now our power is 1. Okay. So in effect, this becomes 12x, because x to the power of 1 is just x. Right? Or right? So we could write this as y dash. That's another way of writing it. So many ways of writing it, but they all have the same thing. The dash is really important. So y dash equals take the power, multiply by it. We don't need to write 2 lines. We know that 3 times 4 is 12. And decrease the power by 1. 2. Done. That's not hard, is it? Okay. So what are the special cases? We've got 2 special cases. One is this one. What's the power of this one? 1, okay? But we couldn't see it there, but it actually is there. So when we take the power and multiply by it, we get 8, and we decrease that by 1. Now what is it? Okay, what's x to the 0? 1. All right? Anything to the 0, including an elephant, is 1. So therefore, that just equals 1. So our answer here is 8. So if we didn't have a power in the question, but we did have an x, all that really happens is the x drops off. But that's the process around it. The second special case is, what if we only have 8? Good. It vanishes altogether. It's not useful to us. It didn't have any x's in it. So by this notation, we are only interested in the things with x's in it. If it doesn't have an x in it, it vanishes completely. So if we had here, you could have something like this. Why, I don't know, but let's say that was there, all right? We know pi is a number, but when we differentiate this, we take the power, we multiply by it, we get 24, we decrease the power by 1, that does not have an x in it, we're not interested in it, we leave it out. All right? Okay, what if we have this? That looks tricky, right? But it's not. It is just 5/3 x to the power of 4. So take the power, multiply by it, decrease the power by 1, we now have 20/3. And leave it like that.
But even though it doesn't have an x, does it still?
It does have an x.
The 3?
No, because the 3 belongs with the 5. It's 5/3.
Okay.
All right, it's a number in front. It's the A. Okay, 2 other things we need to know. If we have something that is something like this that's got brackets around it, we can't differentiate that, and differentiate that. We need to multiply out first. So we need to make this equal to x to the 4 plus 3x cubed before we start. So y dash will equal 4x cubed plus 9x squared. All right? So we need to make sure we multiply it out before we start. All right.